name is Magna, and I'm magnetic. What does that mean? It means that I'm very attractive. Really? Hello everybody, I'm Miss Soul. Welcome to my channel, and today we're going to talk about magnetism. And I have my friend Magna here who's going to help me. Magna is magnetic. What does that mean? Well, she's very attractive. See, Magna has little magnets stuck to her hands, and magnets are objects made of iron or steel that have a magnetic force. What is a magnetic force? Well, it can push or pull objects. Right now we're going to talk about pulling objects or attracting. We're going to see what kind of objects Magna can attract. You can play along too if you want. Can you find a fridge magnet or another magnet in your house? But make sure it's not too strong, and make sure that there's an adult or guardian around to help you. Okay, so let's see. What can Magna attract? What about Ned the Nutcracker? Do you think that she'll attract Ned the Nutcracker? I don't know. I don't think so. I think that Ned the Nutcracker is made of wood. So I don't think that magnets attract wood. Let's try something else. What do I have here? I have some rocks. Well, they look like quartz. They feel heavy. Maybe they're made of metal. Maybe Magna can attract them. Let's try. No go. Magna can't attract rocks. I think rocks are actually made of minerals, so maybe that's why she can't attract them. Let's try something else. This spoon. It's shiny. It's a little bit heavy for the size of it. It might be made of metal, and Magna might be attracted to metal. Let's see. Magna. Look at that! Magna can attract the spoon. Look at that, she can hold it with ease. All right, let's see what else Magna can grab. How about some paper clips? Shiny, they might be metal. Let's see. Woo. Whoa! Look at Magna. Magna also has magnets on her feet. Let's see. Magna! Look at that force of movement. It is attraction, and she is pulling those objects towards those magnet hands of hers. Okay, let's try something else. Let's see, I've got some money back here. How much do I have? Magna can attract my toonie. Look at that, she can pick it up no problem. Oh my goodness, and a loonie. And a dime and a nickel on one foot. And a quarter on the other. Look at that, everyone. Magna is a money magnet. Whoa, so cool. So I think I'm starting to get the hint. I think that there's a little metal here, but it's mostly plastic, so I think that Magna is mostly attracted to metals. What do you think? So we've talked about attracting magnets, or magnets that pull, but what about when magnets push or repel? So I've got these bar magnets, and one side, the red side, is labeled N for north, and the other side has an S for, that's right, south. So we have the blue side is south, the red side is north. Let's see what happens when we hold it against another bar magnet. I've got this bar magnet that I've tied to a string, so we can really see what happens. So I'm gonna try touching the red side, the north side, to the red side. And look at what happens, it pushes it away. So it's repelling. Now, What about blue side to blue side? Let's see what happens. Look at that. Oh, but then what happens now? We've got red side and blue side, north and south, attracting to each other. Now, why do you think this is? The magnetic force always goes this way through the north side and pushes outwards. So if you see these arrows going away from the north side, they're pushing outside, and they go all the way around and go in to the south side. Do you see that? The arrow's going into the south side, away from the north side, and this force creates a magnetic field around the magnet. And so, two norths repel each other or push away from each other. But if I turn them around, because the forces are going in at the same time, that also repels each other because there's still a force created by this movement. But if you turn it around and have the opposite ends line up, what you have is the force from the north magnet being attracted to the pull from the south magnet. See, the force is going in and this is going out. In and out, pulls together. There we have attraction, a pull, a magnetic force. If you see, I have this diagram of the Earth because the Earth is actually a magnet itself. Isn't that amazing? But where do you think the North and South Pole would go? I bet you would probably think that the North goes north, right? Up. North is up here, South is down if you look on a map. But that's actually not the case. It's actually upside down. And we have the South magnet pole at the top, or the north end. And the flow is actually flowing up and in to the magnetic north, but inside it's really the magnetic south. Now, I know that that may sound confusing, but I bet that even your parents may not have known that. So you ask them, see if they knew that already, and see what they think about magnets. And the important thing right now is that you just have fun with magnets and see what you can attract with them. Before we leave today, I want to show you guys one more thing. I want to show you guys the magnetic force, or the magnetic field. Watch. The iron filings spread over the bar magnet get caught on the magnetic field because they're attracted to it. And then you can start to see this pattern. Almost looks like arrows pointing out of the north and going around and then in to the south side. Isn't that amazing? And then look, you play around with this, and because it's iron, it's attracted to the magnet. It moves with it in the same direction. So I think magnets are pretty neat, and I hope that you enjoyed this today, and I hope that you learned something. And Magna hopes that you start attracting things at home yourself. Thanks for tuning in.